Alrighty, so we're going to talk about tangents and normals, and I'm going to use this as an example. It's actually a pretty big topic, but it's also fairly simple if you can get your head around the background, what's happening behind it. So this video hopefully won't be too long, but I want to cover off on the basic principles so that when you come into class you can really be picking up on the nuances. So here's a function. Any takers for what this function is? I'll give you a second. I'll assume you got it right. Y equals x squared is this function. It's a pretty easy one to start with. I've got a point, a coordinate here, which matches that x squared is 2 squared is 4 principle. I'm going to use this as my example. So let's start by talking about what a tangent and a normal curve is. So in orange, first of all, is our tangent. A tangent is a straight line that touches, or tangent to the function, will touch the function at a certain point, which we're saying here is 2, 4, and will have the same gradient as the function does at that point. And that's how it sort of runs along and just touches. If it has a different gradient, it will go through. But it just runs along and just touches that, and it has that coordinate, therefore it has the same gradient where the function does when x equals 2. A normal curve, which I'll do in green, is actually, well, it's not even a curve, a normal line is perpendicular to the tangent. So perpendicular means that it makes a right angle. So if you know the tangent, you can work out the gradient of a normal. But more importantly, you don't even need the tangent, because you can get the gradient of the tangent by finding the gradient of the curve at that point. And how do we find the gradient of the curve at that point? We differentiate. That's how we do it. So we can determine the gradient of either of these. The other thing is, we know a coordinate that the line goes through. So the next question you want to ask yourself is, how do we find a straight line graph if you know a coordinate and a gradient? And you've done this before. So you can definitely do it, but I'll show you again, okay? So let's start with our tangent. We're going to model our tangent here. And I'll do this in orange. So our tangent has a coordinate 2, 4, but also we want to know what the gradient of our tangent is equal to. What is the gradient of this orange line? The way we do that is we investigate the gradient at a certain point on this quadratic function, and we start with y equals x squared, which means that dy dx, or y dash, is equal to 2x. And so that's our gradient function. When you derive, you've got a rate of change function which tells you your gradient. Now I'm going to put in my x value for this function, and I'll get dy dx is equal to 2 times 2, which equals 4. So my gradient at this point is 4. It's quite steep. My graph's a little bit misleading, but it should be quite steep at that point. We've got a gradient of 4. So I can put in here, this is equal to 4. So now, let's do our model. Let's start with the fact that a linear function looks like this. Y equals mx plus c. Okay, you may have just noticed a sudden move of position because I just completely mucked that calculation up. So here we go again. Now we know the gradient, so this is step 1. We know that the gradient m is equal to 4, which means that we have y equals 4x plus c. And we also know, step 2, that when x equals 2, y equals 4, which leads to this. 4 is equal to 4 times 2 plus c, and that leads to c equals negative, almost muck that up again, negative 4, because 4 equals 4, 8 plus c, 4 minus 8 is negative 4, which leads to this function. Y equals 4x minus 4. So it's quite steep, and it crosses down here at minus 4. That's what this is saying. So I'm pretty comfortable and happy with that function works, and that is also an exemplar of how we determine a linear function from a known coordinate and the gradient. Now for the normal curves. Let's talk about the normal. And I'll do the normal in green, because that's what I started with over there. So I'm going to put a little line here, and I'll probably do the normal under there. Okay? Now the first thing is that I'm going to say that m2 is the gradient of my normal curve, and it's perpendicular to m1, which is the gradient of my tangent. And I could call it mn and mt or whatever. But anyway, I've told you that, and you're watching this video, so that's good. So they're perpendicular. That implies, well, one thing which can be converted into something else. It implies that m1 times m2 is equal to negative 1. And I encourage you to look up why this is and have a talk about it, or just have a play with this. You know, one is negative, one of them is positive, so we're going to get a negative there. But also, one of them is quite flat, which means the other one's quite steep. They kind of counteract each other. More importantly though, what this gives us is m2 is equal to negative 1 over m1. So the way you might hear it said, your teacher or me might say, is that m2 is equal to the negative reciprocal, the negative flipped over version of m1. The gradient of the normal curve, or the normal line, is equal to the negative reciprocal of the gradient of the tangent. Anyway, let's have a look at this now and build our understanding. So, I'm going to start with the same process here. 1, m2 is equal to negative 1 over 4, because m1 has a gradient of 4. I've done it there. So m2 equals that, and therefore y equals negative 1 over 4, x plus c. And step 2, we also know that when x equals 2, y equals 4, I get 4 equals negative 1/4 times 2 plus c. This becomes negative 1/2, so I get 4 1/2 because I added on equals c. And therefore, and I don't know whether I'm off the page, so if I am, I'm going to move up here just in case. Y equals negative 1/4 x plus 4 1/2, which could be written as plus 9 over 2 or 4.5 or whatever you want to do. But that is the equation of my normal. And if I plot that equation, it's pretty flat. And it also goes through 4 1/2. This is 4. So my scale's out a little bit, that's 4 1/2. But it kind of makes sense, okay? If this is quite flat, as we backtrack along here, it's not going to rise that much. Anyway, the main things here are that you can, 1, determine a linear function from a point and a gradient. 2, you understand how to get the gradient of the normal using the gradient of the tangent. That's 2. And 3, you know what a tangent and a normal curve are. Once you know those 3 things, putting these questions together is pretty easy. But be warned, this is a treasure trove for complex unfamiliar questions. Or complex familiar questions. Those types of questions that involve lots of different processes. Here's a curve, here's the x-coordinate. Where does the normal line at that x-coordinate cross the y-axis? For example, you would have to derive, find the gradient, find the y value, determine the normal line, backtrack that normal line to find the y-intercept. Or even, where does the normal line cross the curve again? There's heaps and heaps of different types of questions that you might be asked. Or backtracking, here's the normal line, what's the curve? So just be warned, it's a bit of a treasure trove for those types of questions. Anyway, I hope that makes sense. Go and practice, ask questions, do your best, see you next time.